Graph linear equations. Let's start off with our previous example. So I just simplified it down a bit so the answers would be integers and not fractions, since those are kind of hard to see on the graph. So let's get started. First, you would notice that the graph of the line is not in our usual form of y is equal to mx plus b. So first, let's try rearranging it so that it is. So I'm going to start with the top equation. So subtracting x from both sides, we have 2y is equal to minus x plus 6, and then we can divide by 2 on both sides. So then you have y is equal to minus half of x plus 3. So that's our first equation. Now for this one, we're going to do the same thing. We're going to write 2y is equal to minus 3x plus 10, and then we're going to divide by 2 on both sides. So then you get y is equal to minus 3 over 2x plus 5. So that's very good. We know what two equations we have to graph. Pretty much with linear equations, they can either intersect once, so like something like that, so that's the solution, or they can miss completely, so then there are no solutions, since the lines will never hit, or they can be the same line, so then they're infinite solution. So those are the three cases we'll talk about. So first case, hint, it is going to be one singular solution, but let's graph it out. So as an exercise, please try to graph the two lines on your paper before we get into this. So pause the video. Now that you're back, let's try doing it. So putting the y-intercept of 3 here, then the slope is minus 1 over 2, meaning that you have to drop down 1 for every 2 you go like that. So the triangle is going to look something like this. So then I'm just going to draw it out. So something like that. So this is going to be our first line. And always extend it to both sides so you don't miss any solutions. So this is, let's say, equation 1, equation 2. So that's equation 1. Now let me use a different color so you guys can see equation 2. So pretty much here, 5 is going to be the y-intercept, so I'm just going to put that over here. Then you have a slope of minus 3 over 2, so you're going to drop down 3, so 3 for every 2 you go. So this is going to be the trajectory your line's going to take. So then let's just draw that one out. So it's going to be like that somewhat. So that's line 2. So now you can see pretty clearly, they intersect right over here. So that means that the solution to this set of equations is going to be 2, 2. So x, y is equal to 2, 2. So that's fascinating, right? That how this graphical tool is always there for us to sanity check our solution. What you can do on your own is plug back x and y is equal to 2 back into these equations to check if that's the right answer. But essentially, this is a nice way to visualize the problem. So we've looked at our first case of finite solution. Now let's think about infinite and no solution. So let's use red for this new example. So over here, we have two lines to graph. So we'll just put the first line into the normal format. So 2y is equal to minus 2x plus 4 dividing by 2 gets us y is equal to minus x plus 2. Same thing here. This one turns into y is equal to minus x plus 2. So it turns out that equation 1 and equation 2 are the exact same line. So when you end up graphing this, so I'll just draw up a quick set of axes, sorry about that. What will happen is you have our first line which we're graphing, so that's like 2, and then minus would be like that. So that's our first one. And then our second one, we're just going to stack it on top of that, since it's the exact same line. So you're going to notice that these lines follow each other for infinite. You can have like many different points of intersection. So then that means that they have infinite solutions. So we already covered that case. Now let's cover the case of zero solutions before we end this video. So I'm going to erase most of these lines. I'll leave line 1 there. But let's say instead of x plus y is equal to 2, we'll have x plus y was equal to 3. So then line 2 would become minus x plus 3. So then what would end up happening is, let me change color to blue, is that we have our y-intercept up there, and then you can graph that line, same slope, and you will notice that there's always going to be some distance between the two lines, so they never touch, meaning that there's never going to be a solution. So now that we've learned about the 3 different cases of linear equation systems with 2 variables, I think this graphical understanding is good to back up what we touched on 2 videos ago. So thank you for watching this video, and I look forward to seeing you in the next one.